Welcome to the lecture in the data mining course on decision trees. Decision trees are one of the algorithm to perform what is known as a classification task. So, what is a classification task? A classification task is given and an instance, an object, you have to put in one of the number of categories. So, you have a predefined set of categories, you have to put that instance or the object into one of these categories, and these categories are called the class. For example, let us say an object is an email, and I have two categories or classes, spam or non-spam email. So, this is a very common problem all of us face, that we get lot of spam mails and we want to automatically put an email into one of these two categories. So, this problem is known as a classification problem. In this particular case is known as a two class or a binary classification problem. In general, you can have k categories and you would call it a k class problem. Another example, suppose an customer has applied for a bank loan, and in this case the object is that customer, and the object, the customer, is described by a number of attributes. For example, the income of the customer, the age of the customer, the marital status of the customer, the household income of the customer. So, excuse. So, you have a set of attributes describing an instance, and I want to put this customer, the bank wants to put this customer into say into two categories again, whether the customer will repay the loan or will not repay the loan. So, basically like a fraud customer or a real customer. This is another example, again a binary classification problem. There may be other instances. For example, maybe a patient comes to a doctor and the patient has one of possible say 5 diseases, and the symptoms of the patient would be the attributes of the patient, and the classification system, suppose a automated diagnosis system, will use these attribute values and tell whether which of these 5 diseases this patient has. So, this is a 5 class classification problem. So, what we will do in the next few lectures is to study a number of algorithms which will take as input a set of attributes, attribute values describing an instance or an object, and will produce or predict a class or a category to which that instance belongs. The way to do this is the following. So, we have something called a training set. So, these classification algorithms are also sometimes that is I called supervised learning algorithms, supervised algorithms. So, we have a training set where lot of instances along with their categories are mentioned. So, in some attribute values and the category to which they are known to belong, they are already evidence is there they belong to this. For example, the bank will have a list of previous customers with certain attribute values who have repaid the loan and with certain attributes values you have not repaired the loan. Similarly, a medical diagnosis system will have lot of patient cases where these diseases has happened, what is the symptom, just like a doctor does, and a diseases another disease has happened, what has the symptoms. So, this existing experience will be called a training set. And what the classification algorithm is supposed to do is that it is used to take this training set, learn from this training set, and when a future instance comes which is not part of the training set, a new instance, an unknown instance, a new customer or a new patient, you have to predict the class level, the class, we call it a class level. Okay. So, these algorithms, that is why are also called predictive algorithms. They consider historical data, they use historical data and predict on new data. So, we will see a number of algorithms. We will start with the simplest one, which we call a decision tree algorithm. So, let me explain this to you with an example. So, this is what I was mentioning, that this table that we see represents the training set or the training examples. Let us see what this table means. In this toy example, the instances or objects that we are talking about are nothing but a day, a day of the week, or some day of some season. Okay. So, each row in this table describes a day, and so there are D1 to D14, there are 14 days which are previous examples, and each day belongs to one of the two categories, If you look at the table in the slide, there are two categories, whether people prefer to play tennis and outdoor sports on that day or does not prefer to play tennis on that day. So, each day belongs to two categories, whether people play tennis or do not. So, the last column that you see, tennis question mark, is actually the class level of the day. So, I have two possible class levels, yes and no, binary classification. Besides the last column, each day is described by 4 attributes represented by these columns. So, these attributes are, how does the day look like, outlook I call it, it is sunny or overcast or raining. What is the temperature of the day? Again, I do not write numerical values, but I just qualitatively describe it as hot or cool or mild. The humidity of the day, which again takes some value high or normal or low maybe, and the wind condition, which is weak or strong. Okay. So, as if I can think of a day as a 4-dimensional vector consisting of 4 values, the outlook, the temperature, the humidity, the wind. So, for example, day 1 D1, I describe it by this vector sunny, hot, high and weak. Day 10 would be described as rain, mild, normal and weak. Okay. So, and of course, the final column that we see is the class level. So, this matrix is a very common form of representing the data. It is called a attribute instance matrix. The columns are attribute, and there is one particular attribute which is the class level, usually in the last column, and the rows are the instances. So, I have these 14 instances in my training example. What my intent is that after looking at this 14 instances, if I get a new instance, another d I let us say, for which I know the attribute values, but I do not know the class level. So, I know these attribute values of outlook, temperature, humidity and wind, but I actually do not know what the class level is, whether people will play tennis or not play tennis. So, I want to write some kind of rule or some kind of function or rule which will take these 4 attribute values and return a value of the tennis attribute, the class level. That would be my classification rule or classification law or function. And this particular rule or function I would like to derive from my training example. So, one particular type of rule that we are currently interested in is called a decision tree. It takes this particular form, it takes the form of a tree. So, how it does it? First, it checks the value of one attribute in the which is the root of the tree, the root node of the tree. So, in the diagram that you see, the outlook value is a root node, and for each possible value of this root node attribute, I have 3 childs, 3 branches. So, for example, here sunny, overcast, rain, these are the 3 branches. And now, for each of these 3 branches, I can do one of the following, one of the 2 possibilities. Either I can ask a new question, test the value of another attribute. For example, in the branch sunny, I again ask the question, what is the value of humidity attribute? Okay. And similarly, in the branch rain, I again ask what is the value of wind attribute. So, basically this child can either lead to another internal node of the tree, or I can directly set, for example, in this overcast, that if the value of outlook is overcast, it is definitely the class level is yes. Okay. So, I directly tell the class level. So, and I do not ask any further question. In other words, I form a leaf of the tree, I do not branch further. Whereas, in the sunny, I branch further using the humidity attribute into two branches, and then these branches actually they do not branch further. So, they directly tell the class attribute. So, a decision tree is a tree where the nodes are attribute values. and and the branches are the different values that attribute actually takes, and the leaf nodes are some class level. How is this tree gives me a classification rule? So, once I have this tree, once a new instance comes, I just push it down the tree. I first ask what is the value of outlook. Depending on the value, I take a branch. If it is overcast, I directly say the class is yes. If it is not overcast, I take sunny or rain. Suppose sunny, I again check the value of humidity. If humidity is high, I say class level is no. If humidity is normal, I say class level is yes. Similarly, for the wind attribute for the rain branch. So, you see I can use this tree to infer the class level of an instance, new instance, by for which the attribute values I know. I just push it down the tree, see which leaf it leads to, following which branch, like if then else statement, and each branch, each leaf has a class level. Whatever leaf it leads to, that is the class level of this instance. So, this can act as a classification rule. So, everybody of you, please note down this tree in your exercise books. Note down this tree, simple tree. Now, you see, look at each of the rows and see what is the class level you get using this tree. Okay. So, for D1, what I get? Outlook is sunny, I check humidity is high. So, attribute class level is no. Okay. So, you check class level is no. Of course, I will not do it for an existing training example, I do it for an unknown example only. Please note that. So, this is a decision tree. This kind of tree with attributes and leaves is a decision tree. Note that we human beings use this kind of logic. We often use this kind of logic. Okay. If you look carefully, this tree can be represented by some simple Boolean logic function. Okay, of this particular form. So, if you look at this tree and try to write it as a set of if then else rule, you see this is what we get. Okay. If outlook is sunny and humidity is normal, or if outlook is overcast, or if outlook is rain and wind is weak, we have Platen is equal to yes. Do you see a pattern in this? First thing, you verify whether this if then else matches with this tree's inference. Okay, you just check once. You will easily see that this if then else matches it. Okay. Second is you just try to see if there is a pattern in this rule that I have written. You see if there is actually a pattern or not, and think on it. How I am writing this if then rule. Okay, just look at the rule. Look at the nature of the rule. You see if you have any pattern or not. If you have seen carefully, you will see that in each of these if statement I have some and between this if statement I have some or. I have some and I have some or. And what are each of these if? You see each of the branches, of the tree, they correspond to an if. Okay. So, all you need to do is follow a branch, connect this by and. Sorry. Connect this by and. Okay. Similarly, all right. So, I have this branch, another branch, and so on. So, I have this as a branch, this as a branch, this as a branch. Okay. So, this branch corresponds to this rule. Okay. So, what I do is that I write down such AND rules for each branch, okay, and connect them by OR. Okay. So, basically let me take all the yes branches. So, this is a yes branch, this is a yes branch, and let me take all the no branches. This is a no branch, this is a no branch. So, what I will do, I will say if this branch a AND statement, or if this branch an AND statement, yes, or this branch actually, the third branch is there, yes, and then I will say if this branch or this branch, then no. Okay. So, I can write equivalent logical rules for this. So, let me sorry. Okay. Let me give you one more small example. suppose I have this. So, suppose I have a tree like this. So, what would be the rule corresponding to this tree? So, temperature is the root node. I check high and low, then I check humidity. If humidity is high, I check wind. So, if humidity is low, maybe I check something else. If wind is low, yes, play tennis. Wind is high, no. So, I can write it as a rule: temperature equal to high and humidity equal to high and wind equal to low, this path, then yes. Or maybe some other part, temperature equal to low and humidity equal to low and say wind equal to high, then maybe yes again. So, or that. So, this way, so basically what I am doing is that I am writing down a set of AND/OR rules, as a pictorial, as a diagrammatic manner, that is all. And you know that actually any Boolean formula can be written as a AND/OR rule, or of some ANDs. Any Boolean formula can be written like that. So, basically if I write down this kind of tree, I can actually represent any functional functional form. That means any type of function which takes the input, produces the class level. I can do that. Okay. So, also another thing I would like to mention, that if you think carefully, we humans, we actually often use this tree. First we say, suppose this happens, then what I do? If this happens this way, then what happens if something else? If it is raining today and the buses are crowded and there is lot of work, then I have to go to office. If it is not raining today and there is no work, then I will not go to office. So, we use this kind of hierarchical, this kind of tree like decision making often in our practice. So, I am the good thing is that you can write it as a logical formula, you can express any function by this kind of decision tree. Okay. So, this is a popular classifier that people use in actually, if you will go to industry, many of the people use this kind of rule, this kind of decision tree. What we will do next is that, so now I think what you can do from this is, then you have understood the structure of the decision tree, you can use it to predict. That means, when a new example comes whose attribute value I know, you can push it to the tree and predict the class level. So, decision using a decision tree, that much you can do now. But what determining is actually supposed to do, what I will do in the next lecture, is that find out the best decision tree which fits the training set. So, I have these 14 days already example seen, or say credit card fraud, already I have seen previous examples. Find out or learn a decision tree from this previous training example, which will help me give the best prediction. So, using some statistical properties of this table of this training set, I want to learn the decision tree. That is my next task. Okay. So, please practice a few examples. What I would suppose to tell you is that you can look at these training examples, this protein, that the previous slide that I have sorry, the previous slide that I have shown you, sorry, this table, and try to think of yourself, what is the decision tree I should make to best fit this data. Fit this data means it, for every row it gives the correct output, the final column. You try to draw a decision tree from your human intuition, you try to draw it. Okay. And the hope is that if it is doing good on these 14 examples, it will probably do good on the new unknown example also. That is the underlying assumption. Okay. Often that assumption is correct. So, you try to, and you will see that if you think on this intuition of this, I will tell an algorithm to actually quantify this intuition and build that tree. Okay. So, in the next class, we are studying the algorithms for building or construction of decision trees from training set. Thank you for today.